Welcome to the office. We want to take a look at even and odd permutations. In order for us to talk about even and odd permutations, we have to start with this idea of a transposition. So a transposition is just the exchange of two elements, right? So a transposition might be something like, I don't know, 7-11. Swap 7-11. Simple as that. Transposition, cycle of length 2. If I want to, I can recognize that any permutation can be obtained by, right, conceptually here, the book calls it naively, but it's fine. Conceptually, what we can do is we can say any transposition, sorry, not any transposition, any permutation can be obtained by swapping pairs of elements until we end up with the desired permutation. But as we swap pairs of elements, we recognize that each individual swap is a transposition. So we transpose, we transpose, we transpose until we find the permutation that we're looking for. So this corollary essentially says that we can do that for any permutation that we like. What it doesn't tell us is how to express it or how to find it. And that's the considerations of our example here. We want to express the permutation as a product of transpositions. So what I'd like to do is I would like to present what I call the intuitive approach, or at least slightly intuitive, which is, I would argue, what the book expresses is not so intuitive. However, you want to know what the book says in order for you to say, all right, this is my answer, and I can check it with the back of the book. But to get an intuitive answer for this permutation as a product of transpositions, 2,5 is already a transposition, so I don't have to do anything with that. It's only the 1, 6, 3, 4 that I have to rewrite in terms of pairs. How am I swapping pairs? Well, what I can do here is I can recognize that I have 1 going to 6, 6 going to 3, and 3 going to 4. So I want to draw this nice diagram. This kind of brings us back a little ways in our content. So we've seen pictures like this before. And I can recognize that this is given by sending 1 to 6, and then I'm taking 6 and I'm sending it to 3, and then I'm taking 3 and I'm sending it to 4. And that's really all that we need. Since I have 1 included in here already, it actually completes the cycle all on its own. I don't need the 4 goes to 1. If we wanted to verify that, we can do so. So when we're evaluating a product of permutations, I've said it a lot of different ways, or I've said it differently than what I'm about to share now. We can start essentially wherever we want. I don't know what we're working in here. Are we working in S10? Are we working in S3? Well, we're not clearly not working in S3, but we could be working in just S6 or S7, anything larger. So usually we start low and work our way high. We could say, what happens to 1? Well, I actually see something that happens to 1 here. It could be that 1 isn't present. Like what happens to 1 in this? Well, 1 just stays where it's at. 2 goes to 5, 3 stays where it's at, 4 stays where it's at, 5 actually is already handled right there, 6 stays where it's at. But you don't know, right, what are we working in here? If we're working in S10, we would go all the way up to 10. If we're working in just S6, then this is where we could end. But we don't write down these things here, right? We don't write down those fixed elements. Anyway, so I'm going off on a tangent. I apologize. All right, what we're interested in then is where does 1 go to? I start all the way at the right because this is a product of functions. This doesn't change 1. This doesn't change 1. This sends 1 to 6. Fantastic. Now I go and see what happens to 6 under the composition. This doesn't do anything to 6. This sends 6 to 3. This doesn't do anything to 3. So it just goes to 3. What does this do to 3? This sends 3 to 4. What does this do to 4? Nothing. What does this do to 4? Nothing. So we're at 4. All right, now where does 4 go to? Well, 4, right, this does something to 4. 4 goes to 3. So, excellent, we move on. What does this do to 3? Oh, that sends 3 to 6. Excellent. What does this do to 6? It actually does something still. It sends 6 to 1. So that's bringing us from 4 all the way back to 1. So we close our parentheses and we call it good. So that gives us back exactly what we were looking for. So I could give a response of sigma is equal to 5, and then replace 1, 6, 3, 4 with 1, 6, 6, 3, and then 3, 4. And this would be okay. This works. That's not a problem. However, that's not the presentation that the book gives. So if you want to be able to check your answers, which is always really nice, right? That's the purpose of assigning odd problems, which I try to do. So how can we verify our answers with the back of the book? Well, we use the same approach that the book does. The book presents this this statement. 2, 5, of course, is still a transposition, and 1, 6, 3, 4 can be expressed in this way: 1, 4, 1, 3, 1, 6. Interesting. So if I wanted to verify that this is the correct answer, I can use the same approach that I did over here. Again, it's a little bit different than, or here, a little different than what I've done in previous videos. I'm going to ask myself, what does it do to 1? Right, just work my way up here. What does it do to 1? All right, sends 1 to 6. What does it do to 6? Nothing. All right, so 1 goes to 6, and then 6 doesn't go anywhere. 6 doesn't go anywhere. 6 doesn't go anywhere. So 1 to 6. Now we start over. What does this one do to 6? It sends 6 to 1. What does this one do? Sends 1 to 3. What does this one do? Nothing. Doesn't do anything to 3. What does this one do? Nothing. Doesn't do anything to 3. So we go back to here and we start. What does this do to 3? This does nothing to 3. This sends 3 to 1. So now the question is what does it do with 1? And we move on. What does it do to 1? Sends 1 to 4. What does this do to 4? Nothing. So 4. Now we say, what happens to 4? This does nothing to 4. This does nothing to 4. This sends 4 to 1. Hey, we close that cycle. And then we can, and we ask ourselves, okay, we're all set with all of those. 1 is taken care of, 3 is taken care of, 4 is taken care of. 2 is not. Let's see what happens to 2. This does nothing to 2. This does nothing to 2. This does nothing to 2. This sends 2 to 5. Excellent. What happens to 5? This does nothing. This does nothing. This does nothing. This sends 5 to 2. Close. The only other number to consider, well, there aren't any. I wouldn't go any higher than that because that's, all right, 6 is the highest number that appears. So we should be all set, right? We have verified our answer there. And this is suggested by the book. So I'm going to put as suggested by the text. And I'm writing that as a justification for my work. What have I done? I recognized that the book told me that this is what I need to do, so I'm doing it. There isn't really any other work to do. Again, I would argue that this is the intuitive approach, but if you want to be able to check your answers, this is the answer that would be given in the back of the book. So thank you for your time. I'll see you guys later here in the office.